Is the Mpemba effect real? For more than 2000 years, scientists have observed the unique phenomena that in some conditions hot water freezes faster than cold water. In the 4th century BCE, Greek scientist Aristotle noted the fact that the water has previously been warmed contributes to its freezing quickly, for so it cools sooner. 17th century English scientist Francis Bacon noted, slightly tepid water freezes more easily than that which is utterly cold. Several years later, French mathematician René Descartes echoed his predecessor's observations, writing, "One can see by experience that water that has been kept on fire for a long time freezes faster than other." Given the centuries-old knowledge that hot water does indeed freeze faster than cold in certain circumstances, it should have come as no surprise when Tanzanian schoolboy Erasto Mpemba claimed in his science class in 1963 that ice cream would freeze faster if it was heated first before being put into a freezer. And the teacher said, "You were confused, that cannot happen." Mpemba's assertion also amused his classmates, but their laughter quickly turned to a murmur of assent when a school supervisor ran the experiment and proved the young man correct. Scientists have offered many explanations to account for the unexpected phenomena, but to date, none has been accepted by the wider scientific community. Here are a few suggestions. Evaporation. As the warmer water cools to the temperature of the cooler water, it may lose large amounts of water to evaporation. The reduced mass more easily allows for the water to cool and freeze. Dissolved gases. Hot water can hold less dissolved gas than cold water. This may somehow change the properties of the water, making it easier to develop convection currents and therefore easier to freeze. Frost. Frost conducts heat poorly. If the containers of hot water are sitting on layers of frost, the water will cause the frost to melt. This would establish better thermal contact with the cold refrigerator shelf or floor. To date, experiments have not adequately illustrated which, if any, of the proposed processes is the most important one. It seems likely that there is no one mechanism that explains the Mpemba effect for all circumstances, explained Monvia Zheng of the Department of Physics at the University of California in 1998.